Exploring functions using the graphing calculators. So it says that it's fairly easy to have them evaluate expressions. Okay, that's just the calculator, the calculate portion of it, for our rules to generate outputs. So let's think about them graphically. So when we input something graphically, we can look at their inputs and the outputs in a different way. We're going to focus in on the table feature of the calculator and the graphing feature. Those two are going to go hand in hand. So it says, consider the linear function f of x equals 1/2 x plus 2. So that is in the form y equals mx plus b. Therefore, it's a linear function. So when we graph it, we're going to see a line. It says, do the following by using your graphing calculator's table function. So first of all, we've got to go to the calculator and graph that 1/2 x plus 2. So go to your home screen, new document, and a graphing page. And I'm going to enter in our 1/2 x plus 2. And then hit enter. Make sure your x is not in the denominator of that 1/2. That would give you a totally different graph. And enter. All right, so to get to the table function, we've got to hit Control T, T for table. And it's asking us to evaluate at f of -6, f of 0, and f of 8. So those three are the inputs that we're going to have to look at on the table. Remember, those inputs are our x's. So we want to know what output is associated with an input of -6, what output is associated with an input of 0, and what output is associated with an x or an input of 8. So 0, -6, and 8. So we're going to have to scroll through the table to see those values. So hit your up arrow, and we see that 2 is associated with 0. If we continue to scroll through, at -6, the y value is -1, and then we just got to go the other way through the table. So continue to hit the arrow button the other way, and we see that the input is 6. So let's write those down. So at -6, it was -1, 0, it was 2, and 8, it was 6. So now we could write those three as points as well, which tends to make a little bit more sense. So -6, -1 is a point on our graph, 0, 2, and 8, 6. It says explore the table to determine the value of x for which f of x equals 11. So now they're giving us the output, or they're giving us that y value. We've got to find the x value that's associated with it. So right now we know x 11. All right, we're going back to our table to determine what x value is associated with a y value of 11. So again, continue to navigate through that table, but now we're concentrating on the y list. And you can see that a y, or that output of 11, came from an input, or an x value of 18. So this point would be 18, 11. It says use the table to fill out the following table and graph the function on the grid for the interval. -6 is less than or equal to x, which is less than or equal to 6. So in this one, we talked about this in class, they're giving us a specified domain. So when they give us that specified domain, we have to make sure that we don't put arrows on our graph, because they just want to see that little chunk of the graph. And in this case, because it's linear, we're not going to see the complete line, so no arrows. We're just going to see a line segment. So if you go to the table and we start that table, okay, scroll back up to -6, while we move through that table, and you can see that our table is going to start at -1 and then continue through. And they're asking us for specific values. They're saying an x of -6, then they want you to jump down to an x of -4. So they're avoiding that, that -1/2 or that -0.5, and they're doing the same thing. They're skipping over -3. So they're just putting in the integers, and that's fine. So let's go back and fill in that table. So we have a -1, 0. Go ahead and pause the video, fill in your Y list, and then make that a point. Okay, so go ahead and check your table according to my table. Make sure you fill in the Y's, and then make sure that you've written them as coordinates, meaning an XY pair. And part D says, graph the linear function g of x equals f minus x on the same set of axes and find where the two lines intersect. So we've got to graph that first function, okay, that we just filled in that table for, okay, that f of x. So go ahead and, again, pause the video and graph those points right there. Draw your line in. Well, it's actually going to be a line segment because of that given domain. And then we'll come back and we'll do part D. Okay, so your graph should look like mine. Make sure, again, that there's no arrows on this because of that domain, and also put your label on the graph. Part D wants us to graph g of x equals f minus x on the same set of axes and find where they intersect. So let's go back to our calculator. And to close that table so we can just see the graph, if you hit Control T again, that will collapse the table and you'll get that full graph back. So if we need to type in a second function, we have to hit Control G for graph. So we've got f2 of x, so that's going to allow us to enter in 5 minus x and hit enter. And now we see f2 of x. Okay, once that blue one had that positive slope of 1/2 and a y-intercept of 2, and this second one that we just graphed has a y-intercept of 5 and a slope of -1/2. So what they want us to do is they want us to find that point of intersection. So let's go ahead and produce this graph on our paper. So let's examine the table. So if we look at Control T again, okay, our table is now going to have that same x list. It's got our f of x, our first function, then it's got our f2 of x, the second function. So if you arrow over to the right, you can see both of those, or all three of those columns. So let's pick some points off of this third column here to generate our f of x, or excuse me, g of x, 5 minus x. Go ahead, pause the video, graph that one, and that one they didn't specify a domain, so go ahead and put arrows on that graph. Okay, so you should have both of those functions graphed on that same set of axes, and they're asking us to see where those two lines intersect. So I see that point of intersection right there from my graph, and I know that it is 2, 3. Looking at the graph that we generated ourselves, I can see that point of intersection. Well, let's look at it on our calculator and see what the calculator can do for us. So again, let's collapse out that table. Well, let's keep the table for right now. We know that it's 2, 3, so let's scroll through our table and see how we can visualize it on our table. So if I move through my table, I notice that both my outputs are the same. So I have an output of 3 for the first function, output of 3 for the second function with that input of 2. When those outputs are the same, that indicates that there has been an intersection on the graph. So now you can see where it is on the table. Control T to collapse that table. Now how can we do it just on the graph? So if you go over and you hit Menu, find that Menu button on the right-hand side, and you go into Analyze Graph, so that's number 6, and then you go to choice 4, which is Intersection. And you start to see that dotted line with that finger moving that line back and forth, and it asks you a question down at the bottom, and it says lower bound. The lower bound just means be to the left side of the point of intersection. It doesn't matter where you are, as long as you're somewhere to the left of the point of intersection. And then use your click pad and click it. And then it changes that question and it says upper bound. Upper bound means move that line somewhere to the right. And as you cross over the point of intersection, the calculator, and click it again for that to disappear, the calculator gives you that point of intersection. So if you hover over it and hold your click pad down so that little hand closes on whatever text is there, you can move it around. So you can move those labels around, or you can move that point, and the calculator can give you that point of intersection as well. Right? So now it says, show that the point that you found in D is a solution to both equations. Okay, so let's show that algebraically. So essentially we're doing a check. So if we know that the y is 3, 1/2 of x plus 2, and we go and we check that and we absolutely get it true, and do the same thing with the second equation. Does 3 equal 5 minus 2? And that is true as well. Okay, go ahead and flip the page. It says the graphic calculator can do the heavy lifting with calculations while we examine the results. Always be careful when entering your algebraic expressions on your calculator. So now let's take a look at a quadratic function using that graphing calculator. So how do I know that this is a quadratic? It's got this, if it has an exponent of 2, if that's the highest exponent there is, then that is considered a quadratic. I'm just going to kind of play around with this today. Later on in the year, we're going to do quite a bit with quadratic functions. Okay, this quadratic function, and it gives us an interval. So again, it's got that specified domain, so we aren't going to put any arrows on this. They just want to see from -1 to 4. It says, do the following with the use of tables on your calculator. So let's go home and a new document, and don't save it, and open up another graph. So we're going to type it in exactly the way we see it, with parentheses and all. And hit enter. Okay, so we've got a parabola. And now let's go to our table, Control T. And they want us to graph this from -1. So you may need to arrow up to -1. And they want from -1 all the way to 4. So let's generate that table and copy the table down onto your paper. So just a simple T-chart, -1 all the way up to 4. And then fill in the y values that correspond with it. Go ahead, pause the video, and graph those points. Okay, so your graph should kind of look like that little hook. And let's go ahead and put a label on it as well. And that's y equals quantity x minus 1 squared minus 4. Now we're going to ask some questions about this. What are the function's minimum and maximum values? So the minimum value, we're going to talk absolute max and absolute min. They didn't specify that they wanted the relative max and the relative min, so when they don't specify, go with the absolute. So the absolute max is, we end up with 1, 2, 3, 4, 5. And the absolute min is -1, 1, 2, 3, -4. Oops, +1, -4. And then it says over what interval is the function negative? So just by looking at that graph, what interval is the function negative? And it's negative where it lies below the x-axis. It's positive where it's above the x-axis. So our function is negative below the x-axis, and we have to state that in interval notation. So it's negative from there all the way over to the other side. So that goes from negative 1, I'm going to use interval notation, all the way over to 3. If you choose, whoops, no brackets, we've got to use parentheses because it starts here at 0, and 0 is neither negative nor positive. So we've got to make sure that we indicate that in our interval notation with a parenthesis. Negative 1 to 3. If we choose to put it in inequality notation, it's negative 1 is less than x, which is less than 3. No equal to. For your graph, state the interval over which the function is increasing. So that's that positive rate of change. So our positive rate of change, where it looks like it's going uphill, and stating that interval, again, that starts at positive 1, and it increases all the way up to where the x is 4. And inequality notation would be 1 is less than or equal to x, which is less than or equal to 4. How can this graph help solve the equation? So here was our original graph, and now they're saying when it's equal to negative 3. So when it's equal to negative 3, we've done this in our past 2 lessons. 1, 2, negative 3 is that line right there. Okay, because this right here, our original function was y equals this. So that negative 3 is also a y. So where do those two intersect? They intersect right there. So we know we just solved an equation that we are totally not familiar with. So what are our x values where they intersect? X of 0 and an x of 2. Okay? So I think that's pretty cool to be able to solve an equation graphically that we don't know how to solve algebraically yet. Okay. And then it says, which of the following is a point where this line and this line intersect? So I'm not going to spend more time on this. I'm going to let you guys do this one on your own. Graph both on your calculator, and then either use the table feature to see where the inputs are equal, or use that menu intersect feature, and your answer is choice 3.